Hi everybody, so we're not going to do anything new today. We're going to practice everything from the last three lessons or so. Everything on statistical distributions. Because some of the earlier stuff, as you can see here, you're quite possibly forgetting how to do already. It's not that difficult, but we do need to repeat it a few times to get it into the old brain so that we can retrieve it easier. So pause the video and give this one a go. Right, so we want a table for the probability distribution of x, so that means we're going to have x and we're finding the probability, so they've given us the format that we write it in, the big X, which is the random variable, equaling that. So the probability that we get a 1 would be, they're saying whatever the value is that you want out of 21, so 1 out of 21, and it's just going to be like that all the way, so that you should end up with something like this. Now I never bother to put anything in its simplest form here because I want to remind myself that these should all add up to 1, and if you add up 1, 2, 3, 4, 5 and 6, triangular number, you get 21 out of 21, which is a whole, isn't it? Now the probability bigger than 2 or up to or equal to 5 means it's got to be one of these three results, doesn't it? So it's going to be 3 plus 4 plus 5 all out of 21. So that gives us 9, 10, 11, 12 out of 21. And you can simplify it then if you want, but you don't have to. Here's your second question. Very similar to the last one. The only difference is a slightly more tricky process to find out what your probability is. So pause the video and give it a go. And hopefully you'll have something looking like this. I'll just do the last one with you in case you're not sure. So when x is 4, the probability is going to be 3 4s are 12, take 1 is 11 out of 26. Again, if you add these numerators up, you should get 26, so you've got a whole. Probability bigger than 2 and or equal to 4 means those two, doesn't it? So add 11 and 8 together will give us 19 out of 26. Third question, something very similar, only we've got this unknown value of k. So go through the same process, make an equation, solve it. I'll pause the video now. And hopefully we are saying probability, oh it's not that, is it? It's y. So probability of capital Y equals y, and then for 1 it'll be 1 over k. For 2 it'll be 2 over k. For 3, 3 over k. 4, 4 over k. And 5, 5 over k. Now all of these probabilities have to add up to 1, so looking back at how we did it the time before, I just wrote all the numerators over the common denominator, didn't I, is equal to 1. Then it's quite easy to see if we multiply both sides by k, we'll get k on that side, add up the numerators, 9, 12, 14, 15, you should have k being equal to 15. And then the table is just going to be replacing the 1 with those 15s, and then you're finding a probability. Giving us a table like that, probability bigger than 3, well we're just interested in 4 and 5, so it's 4 plus 5 over 15, which is 9/15, or 3/5 if you prefer. Okay, that's the first half of our questions. We're going to have 3 which start moving on towards your binomial stuff. Okay, here's the next question. This is what we're talking about as a normal distribution. Anyway, so pause the video, have a really good go at this. You may need to take a fair bit of time to think about it. Right, I'll go through the first 2 parts first because it's kind of a 2-part question. So we're thinking about how many times he's rolling the dice. So we've got our random variable t represents the number of times he rolls a 6. He's rolling it 4 times. So he could roll 4 sixes. He could roll 3, 2, 1, or no sixes at all. And we're going to have to work out all of those. So then we would be saying the probability of capital T equaling a little t that we've got up there. And we're going to do these one at a time. So the end ones are the easiest. So the very first one, we're going to have to get 1 6 is 1 over 4. So to get 4, we're going to need 1 in 4 chance to happen 4 times. So that'll be 1 over 4 to the power of 4, which is 4 to the power of 4 is 256, so it'll be 1 over 256. So that's that one. And we could close out this one at the same time. What's the chance of getting none at all? Well, that's going to be 3/4 to get not a 6, isn't it? For that to happen 4 times in a row, you're going to have to do that again. So you're going to get 4 to the power of 4 on the bottom, and you're going to get 3 to the power of 4, which is 81 on the top. Now, the thing we have in the middle is we've got, if we go for 3, there are going to be 4 different ways of choosing this, but in case you've forgotten how we do that, then we could look into onto the calculator, and where would we be starting? Right, we're looking for it's probability, so we go option, arrow across to probability, hit probability, and it's NCR. So we've got 4 different things, 4 events, and we are choosing 1. Actually, we're choosing 3, aren't we? Sorry, we're choosing 3. But it's the same thing, actually. It's going to give us a total of 4. Then we're going to be multiple. So we've got 4 choose 3 times, we want that to happen 3 times, but 1 time for it to be not a 6. So we're going to have a quarter in there. So you're then going to be putting in times 3 over 4 cubed times 1/4. And that's giving us 27 over 64. I think it's going to be a good idea to keep everything with the same denominator because it allows us to check. So that's 4 times that, isn't it? So 4 times 27 is 108. And then you're going to continue that process, which should look like this. Now notice I've swapped my 1 and my 3 over because I got myself a bit confused there. So we've got it happening 1 time being 108 over 256, happening twice being 54 over 256, and happening 3 times being 12 over 256. And then it asks us to find the probability that t is less than 3. So that means the number of 6's being less than 3. So it's those 3 results added together, which gives you 243 out of 256. Then we move on to the second part. Now here he's rolling the dice a maximum of 5 times, so we need a table that's going from 1 to 5 because he's definitely going to roll it once, and then we think through each bit one at a time. And hopefully you should come up with something that looks like this. And first up, if he only rolls it once, that'll be because he's got a 6. That happens 1 time in 4. So that one's the easiest. And then you're going to go for just thinking through what happens. For it to be twice, it must be not, and then a 6. So that would be 3 times 1 is 3 over 16, wouldn't it? Then for the next one, that would have to happen if we put another 3/4 in front of that, which would give us 9 over 4/16 is 64. And this is going to happen if we had a 3 and 4 chance happening 3 times, which is going to give us 27, but out of 4 to the power 4 is 256. And then the final thing that would happen would be 1 take all of that, because you're only going to do it 5 times. So if you add all of those together, take it away from 1, you get 81 out of 256. Then finally, we just need to know the probability that the number of times he rolls it is greater than 2. So greater than 2 is those 3 there, isn't it? So the probability that S is bigger than 2 is going to be 9/64 plus 27 over 256 plus 81 over 256, which should give you, out of 256, 144, and we can simplify that to 9/16. Okay, here's your next question, so pause it and give it a go. Right, so the conditions, you're basically looking for 4 conditions. One is there's only 2 things that can happen, success or failure. One is that everything that happens, all the trials are independent of each other. A third is that you've got a fixed number of trials. And the fourth is that the probability of the trial happening is always the same, which is pretty much the same as it being independent. Right, so that's that. I'm not going to bother writing that down myself. So part B, finding the probability that you will have at least 2 successes. Well, first of all, we're saying that x can be done as a binomial. We're thinking about 10 houses, and the probability of success is 0.05. So he's looking for the probability he's going to be successful at least 2 times, so greater than or equal to 2. And what we need to do is go back to the calculator, and we need to go to statistics mode, and we need to go to distribution and to binomial, and then we want cumulative distribution, so that's BCD, and then we need to fix what we want. So we want 2 to be the lowest amount that could happen. We want there to be an upper amount of top one of 10, and that the number of trials is 10. Probability is already at 0.05, so I just press execute a couple of times, and I get 0.0861. Always write it down to 4 decimal places, because that's what will be in the tables if you decided to go that route. Now the next part has got 4 marks, and we haven't done something called logarithms yet, which would make this a lot easier. Without knowing logarithms, we're going to have to use a little bit of trial and error. But what we're thinking about, so we want at least 1 success. So one thing you could say is that if you knew the probability of getting no successes, you could take that away from 1. So probability of 0 success has got to be less than 0.01. So we're looking for the point at which, and what's happening each time. So we're having being unsuccessful is a chance of 0.05, isn't it? So we're looking at, the probability of being unsuccessful is 0.95. So I'm wanting 0.95 to a power such that we get, sorry, not equal to, we get a value of less than 1%, don't we? So we're going to just keep on doing that. And logarithms would tell us what that power is. Otherwise, we're looking at chucking it into the calculator as many times until you find that one. And if you found 90, then well done. But don't worry, we will revisit this when we've done logarithms. Today's final question, pause it and give it a go. So this first one, we've got a probability of 0.6 and we've got our number of arrows as being 20. So we want to know the probability she hits it with at least 50% of her arrows. So we want the lower limit, so we want the probability that x is going to be greater than or equal to 10, don't we? And we're going to chuck that into the calculator. So 10 will be the lower, the upper will be 20, and the number of trials is going to be 20, and the probability that she hits the bullseye is 0.6. So that is 0.8725. So now she's shooting 12 sets of 20 arrows, and we all know the probability that she hits it with at least 50% in 7 of the 12 sets of arrows. So we've got a whole new thing. Let's call this one y. This is going to be a different thing, isn't it? This time we've got 12 sets, and we know that the probability that she hits it with at least 50% of her arrows in one set is 0.8725. So that is what we're going to be thinking about. We're now wanting her to hit the bullseye with at least 50% in 7 of the 12 sets. So that is not saying at least, it's saying 7. So that's equal to 7. So now we're going back to here, and our lower is 7 and our upper is 7, and we've got this time 12 trials, and our probability is 0.8725, and that's giving us only a 1% chance, 0.0103. And then finally for part, so that was part A, that's part B, for part C, she's wanting it in fewer than 6. So this time we're saying the probability that y is going to be fewer than 6 is going to be actually, we want our lower thing to be 0 and our upper thing to be 5, because it would include 5, wouldn't it? And our probability is just the same, so let's go for it. And ooh, really, really unlikely, 2.4 times 10 to the negative 4, so that's going to be 0.24, isn't it? And that's all for today, folks. So we had a slightly new thing there of a distribution within a distribution. It can sort of ramp up and see how it goes from there. Okay, great stuff. Well, see you next time. Cheerio.